Hello everyone, I'm Alexander Lakamara. I'm instructor in the Department of Electrical Electronics Technology. Welcome to Electronics Device and their Application course. Today we will learn about semiconductor diodes and diode circuits. In this unit, we have four main topics. In the first topic, semiconductor and diodes. So, in subtopic of this, about classification of material, about semiconductor material, and also how to form semiconductor diodes. In the second topic, diode analysis, like ideal versus practical. That means characteristics of diodes, and also diode equivalent circuit, how to analyze a simple diode circuit, like by using load line analysis. In the third topic, diode circuits, that means diode applications. How diode configure, like parallel, series, parallel series configurations. How to use a diode like gates or gate and gate by using a diode, and also diode rectifiers. In the last topic, about special diodes like light emitting diode, Zener diodes, etc. First, what is electronics? Electronics is the branch of engineering which deal with the current conduction through a gas, a vacuum, or semiconductor. That means an electronics device is a system or other device that in which current flows through a gas or a vacuum or semiconductors. And also when we see the history of development, electronics over the last 7 years or 8 years, semiconductors become a crucial element in manufacturing of electronics. Since the invention of transistor, the word electronics becomes a radical change in terms of research, in terms of development, and in manufacturing, bring out new device and technology. So an electronics device all about handling information. That means high-speed transmission application and processing in the field of industries and manufacturing, like communication, art, medicine, and even warfare. But all of this can be dialed back to the heart of modern electronics system and manufacturing. Even though an electronic system is manufactured with the help of metal, insulator, and semiconductor, but must be considered the backbone of an electronics is a semiconductors. As we studied in the last semester, in the course of electrical electronics fundamental about atom. So all matter is made up of atom. So what is atom? Atom is the smallest part of substance. Atom have a nucleus with electron in motion around it. So the nucleus is central part of an atom. The nucleus is composed of proton and neutron. In general, atom have three elements: electron, proton, and neutron. Electron have a negative charge particles, proton have a positive charge particles, and neutron are a neutral. So electrically, all material fall into one of three classifications. So how to decide it, these materials? So must know about valence electron. So valence electron is the outermost shell of an atom or energy level of an atom. So that materials have less than 4 valence electron, we can call it conductor. So conductor are materials that have low resistivity. So what does it mean? Current can be flow freely or free electron movement like copper, aluminum, silver, etc. Thus matter good conductivity type of matter. But when the material is greater than 4 valence electron, we can call it insulator. Insulator opposite as a conductor, opposite of the conductor. So what does it mean? High resistivity materials in mega ohm. So no free electron movement. Current cannot be moved freely. That we can call it like PVC, rubber, plastics, etc. But when the material is equal to 4 valence electron, we can call it semiconductor. Semiconductor. So the semiconductors have the resistivity less than an insulator and more than a conductor. And our semiconductors have a negative temperature coefficient. Negative temperature coefficient. What does it mean? When resistance of semiconductor increase, the temperature decrease and vice versa. Semiconductor materials can be classified into intrinsic semiconductor and extrinsic semiconductor. Let's see one by one. What is intrinsic semiconductor? A semiconductor in an extremely pure form is known as intrinsic semiconductors. So what that means? When intrinsic semiconductor electronic bonded, that means silicon 4 valence electron and with another silicon 4 valence electron. So each the outer electron can be attached each other. This attachment we can call it covalent bond. So intrinsic semiconductor means the number of electrons and the number of holes are equal. Electrons and holes are only created by thermal extensions. Thus, free electrons and holes are created in the covalent bond. So the total current of this intrinsic semiconductor is the sum of free electron and holes. So the conduction capability of intrinsic semiconductor small at room temperature. In order to increase the conduction capability of these intrinsic semiconductors, it is better to add some impurity materials. The processing of some impurity materials to intrinsic semiconductor, we can call it doping or extrinsic semiconductor. So what is extrinsic semiconductor? It is a semiconductor doped by addition of small amount impurity which is able to change its electrical properties or conduction, making it suitable for electronic applications. This is achieved by adding a small amount of suitable impurity, having 3 valence electron or 5 valence electron, to a semiconductor, pure semiconductor, having 4 valence electron. It is then called impurity or extrinsic semiconductor. The process of adding small impurity to a semiconductor is known as doping. So depending upon the type of impurity added, extrinsic semiconductor are classified into N-type extrinsic semiconductor and P-type extrinsic semiconductors. Let's see one by one. What does mean N-type semiconductor? A small amount of beta-valent impurity materials is added to pure semiconductor materials. The result N-type extrinsic semiconductor. It has 5 valence electron. Let's say example, arsenic added to germanium pure type semiconductor. Arsenic has a 5 valence electron and germanium is type of pure semiconductor 4 valence electron. What's happened? Arsenic have 5 valence electron. Germanium have 4 valence electron. So the 4 valence electron attach with 4 valence electron of germanium and arsenic. One, it remain. This we can call it excess electron. So this atomic bonding germanium crystal with adding impurity of arsenic atom, we get one excess electron. So this excess electron we can call it donor to provide electrons to semiconductor crystals. So this type we can call N-type extrinsic semiconductor. What about B-type semiconductor? When it's about N-type semiconductor, when a small amount of pentavalent impurity is added to a pure semiconductor, we can call it N-type extrinsic semiconductor. The addition of pentavalent impurities provide a large number of free electrons in the semiconductor crystal. That means the added impurities has 5 valence electrons. Electrons are said to be the majority carrier, whereas holes are the minority carriers. Such impurity which produce N-type semiconductor, we can call it donor impurities because they donate or provide free electron to the semiconductor crystals. When you see this schematic, the adding impurities like phosphorus atom to pure semiconductor silicon atom, we can get one extra electron. The 4 valence electron of the silicon, it can attach with phosphorus 4 electron. The phosphorus electron has 5 valence electron, So one excess electron cannot attach it with the silicon because the silicon has 4 valence electron. So that space we can treat it as free electron or extra electron. So this extra electron that we can call it a donor. So as this n-type material, electrons has majority carriers and holes are a minority carriers. P-type semiconductor, when a small amount of trivalent impurities added to pure semiconductor to result B-type extrinsic semiconductor. The added impurities has 3 valence electron. Example, boron has 3 valence electron. When this boron added to germanium atom, germanium has 4 valence electron. Germanium, one type of intrinsic semiconductor because it has 4 valence electron. So the 3 of valence electron form covalent bond with boron, but one remaining electron in germanium cannot form a bond because boron has 3 valence electron and germanium has 4 valence electron. So this space treated as holes. So in other name, we can call it acceptor. It accepts electrons. So this electronic bonding or this type of semiconductor, we can call it p-type extrinsic semiconductor. There occur a potential difference between both regions. Due to the formation of ions across this junction, we can call it potential barrier, as it prevents further movement of holes and electrons through this junction. So potential difference is differ according to their type of semiconductor. If the semiconductor is silicon, the VD becomes 0.7. If the type of semiconductor is germanium, the potential difference becomes 0.3 ions. Now this region is now free from movable charge carriers. The ions present here have been stationary and maintain a region of space between them without any charge carriers. As this region act as barrier between B-type and N-type materials. So this region we can call it barrel junction. Barrel junction, or in other name, depletion region. That means deplete both regions, the P-type and N-type matrix depletes. Now, in this junction, there exists region where positive ion and negative ion are formed. We can call it p-n junction or junction barrier. The formation of negative ion on the side of P, the formation of positive ion on the side of N results the formation of a narrow charge region on the side of p-n junction, on either side of p-n junction, so that we call it n ion, that we call it p ion on the side of n and n ions on the side of p. That n ion means negative ion, p ion means positive. As both of them travel towards the junction, holes and electrons recombine each other, so to neutralize and form ions. Formation of a diode. How to form a diode? If p-type materials and n-type materials are brought close to each other, both of them join to form p-n junction. That's what we call it. A diode is a two-terminal electronic component with p-n junction. So the p-type materials has holes as a majority carrier and n-type materials has electron as a majority carrier. As opposite polarity attracts few holes in p-type materials tend to go to n side, whereas few electrons n-type materials tend to go to p side. A semiconductor diode is a two-terminal electronic component with p-n junction. The symbol of the diode, as seen in the picture, two needles, when the anode, which is on the left side, a positive terminal, the other side in the right side, cathode, which is a negative terminal, the cathode represented as a K, the anode represented as A. The p-type semiconductor, when a small amount of trivalent impurity is added to a pure semiconductor, we can call it p-type exclusive semiconductor. The addition of trivalent impurities provide a large number of holes in the semiconductor. Such impurity which provide p-type semiconductor. We can call it as acceptor impurity because the holes create can accept the electron. So the added impurity has three valence electrons. Electrons are said to be the minority carrier, whereas holes are the majority carrier. When you see in this schematic diagram, boron is one example of trivalent valence electron. So when the boron added to pure semiconductor, like to silicon, the silicon has four valence electron. So the three valence electron attached with the three valence electron of the boron. But one electron of the silicon cannot form a bond or cannot attach it because boron has three electrons. So boron miss one electron. So the silicon that not attached with the boron, the space is treated as a hole. So that hole we can call it acceptor. So the majority carrier of p-type, the positive particles, or we can call it holes, was the minority carriers as electrons. So by this principle, p-type has majority carrier are holes, minority carriers are electrons.